Have you ever just stopped and wondered, what is everything really made of? Today, we're going to trace an idea from a philosophical guess way back in ancient India, all the way to a golden rule that basically governs the entire universe.
It sounds like such a simple question, right? But it's one that we humans have been obsessed with for thousands of years. What are you? What am I? The stars, this planet? What are we all fundamentally made of? And yeah, this question is definitely not new. For centuries, brilliant thinkers from all corners of the globe have wrestled with it, trying to understand the very fabric of reality, to see what's going on beyond what our eyes can see. So our story starts way back, around 500 BC. And what's amazing is that thousands of miles apart, thinkers in both India and Greece were asking this exact same ancient question, completely independent of each other.
Over in India, a great philosopher named Maharishi Kanat came up with this really cool thought experiment. He said, look, what if you take any substance, any padarth, and you just keep dividing it? You cut it in half, then in half again, and you just keep going. He figured that eventually you have to reach a final tiny particle that you just can't divide any further. And he gave this ultimate particle a name, Parmanu.
Now, another philosopher, Pakuta Katayama, he built on this idea. He suggested that these Parmanu particles don't just exist by themselves. Nope, they combine in all sorts of different ways to form everything we experience, solids, liquids, you name it. And this is where it gets really fascinating. At almost the exact same time, halfway across the world in Greece, two other philosophers, Democritus and Leucippus, proposed the very same idea. They called their indivisible particles atoms, from the Greek word atomos, which literally means indivisible. How wild is that? Two totally separate cultures arriving at the same profound conclusion.
So, here's the crucial point. As brilliant as these concepts were, they were purely philosophical. They were just ideas, born from logic and reason. There were no experiments, no physical proof to back them up. For the time being, they were just incredible thoughts. All right, let's hit the fast-forward button a couple of thousand years. By the end of the 18th century, the whole game had changed. We weren't just thinking anymore. We were measuring, we were experimenting, and we were asking a whole new set of questions.
By this point, scientists had the basics down. They understood the difference between simple elements, like pure oxygen, and the compounds they form when they combined, like water. But, knowing that they combined just led to even bigger questions.
The big mysteries were now things like, how? How do these elements combine? Are there rules? What's actually happening on a fundamental level when one substance transforms into another? The answers to these questions would come from a brilliant French scientist named Antoine Lavoisier. And his secret weapon? It wasn't just that he was mixing chemicals. It was that he was carefully, meticulously measuring them. Through all his careful work, Lavoisier established one of the most fundamental laws of nature, a true golden rule that governs every single chemical reaction in the entire universe. He focused on a really specific question. When you burn a log, it seems to kind of disappear, right? It just turns into this light ash. It really looks like the mass is lost. But is it? Does the total mass of everything involved actually change during a chemical reaction? Lavoisier's answer was a huge, resounding no. And his work led to what we now call the law of conservation of mass, which states with this beautiful simplicity, mass can neither be created nor destroyed in a chemical reaction. So let's break that down. It just means you can't make matter appear out of thin air, and you can't make it just vanish into nothing. The total amount of stuff you start with in a reaction is the exact same amount of stuff you end up with. It might just be in a completely different form. Okay, so how did he prove it? Well, not with philosophy, that's for sure. He proved it with a simple, elegant, and perfectly controlled experiment that anyone could see with their own eyes. The experiment is just brilliant in how simple it is. You take two chemicals, you place them in a sealed flask so nothing can get in or out, and then you weigh it. After that, you just mix them, let the reaction happen, and then you weigh the exact same sealed flask again. Now that little cork is the secret to the whole thing. It creates a closed system. That means if the reaction produces a gas, it can't escape and be lost, and no air from the outside can get in either. It guarantees you are weighing the exact same collection of atoms before and after. And the result? The weight is exactly the same. The substances inside have completely transformed, but the total mass hasn't changed by a single microgram. That's the proof right there. This simple experiment gave us the hard evidence we needed. That ancient idea of indestructible particles was finally being proven in a lab. The total mass of what you start with equals the total mass of what you end with. The law holds. So it all comes down to this really powerful summary. Whether you're philosophically dividing matter into smaller and smaller pieces like Maharishi had, or scientifically reacting chemicals in a flask like Lavoisier, you run into the same fundamental truth, nature's golden rule. Mass is never created, nor is it destroyed. And so, from a philosophical question to a cornerstone of chemistry, this law governs everything from baking a cake to the explosion of a star. It's a beautiful reminder that in our universe, all the pieces are already here. They just keep getting rearranged.